And welcome to episode 5 of TimeXtender Tuesdays. We are recording this session so you can share it with your friends and you can go back and review it on YouTube. We'll be posting it up a little bit later today or early tomorrow on YouTube, and we'll send you all a link about that. We know that all of the attendees are muted. So if you have comments or questions, put them in the chat and we will be monitoring the chat, and we'll try to respond to your question as we go throughout the session. And if we get to the end and haven't gotten them all, we'll have a little Q&A session there at the end. My name's Jay Leon. I'm Global Partner Marketing Lead at TimeXtender. And in the next 30 minutes, we're going to have a short demonstration, take your questions, and play Stump the Chumps. We know that we're in that last little part of the year before the Northern Hemisphere summer break, so everybody's time is super valuable, and we really appreciate your taking the time to join us today for this 30-minute TimeXtender Tuesdays. With us presenting today is our Solution Specialist Director, Joseph Treadwell, and Solution Specialist Taylor Hagan. And as you have come to expect, we have a very special guest playing Stump the Chumps. With that, I'll turn it over to Joseph Treadwell. Take it away, Joseph.
Awesome. Thanks so much, Jay. Great. So today, as Jay mentioned, we're going to be using Azure SQL Database Serverless for the MDW storage. So I'm going to walk you through setting that up here in TimeXtender. If you've been following along with these sessions, you'll know that we've been building the TimeXtender reference architecture with Azure SQL Database. You can, of course, follow along in the knowledge base in these articles. We'll see these links posted here in just a moment. And you can walk through and see how to create every one of these different pieces here. But we're creating them on screen. We've recorded all the previous sessions, and you can see these recordings in our YouTube playlist. You just go to youtube.com/TimeXtender. You'll see that TimeXtender Tuesdays playlist. As we've mentioned here, we've gone through and done previous sessions here, creating the app server, creating the project repository, the ODX, the Azure Data Factory, ingesting some SQL Server on-prem data using the integration runtime, which we did last time. And now we're going to be using the Azure SQL Database Serverless as the storage for the MDW. We're also going to be using the Azure Data Factory to transport the data from the data lake into the SQL database. And I'll talk about why we're going to do that. So as you'll see here in this diagram, again, we're going to be using the Azure Data Factory to move data from the Azure Data Lake into the Azure SQL Database Serverless. And the reason why we're doing that is because in the ODX, in the Azure Data Lake, TimeXtender is storing data in a Parquet file. So this Parquet file can be a little bit time and energy intensive in order to get the data out of that file, just parts of the data. So really you have to unpack the entire file to get the data out. Typically, this is going to take something like Databricks or Azure Synapse SQL on demand, something like that, to be able to query this data. So if you're not using Azure Data Factory, what the ODX does is it loads the entire file onto the app server into memory, and then attempts to write the data in batches into the SQL Database Serverless. So what can happen, especially if you're running in a high concurrency, is you load multiple files into the ODX app server, and you can fill up the memory on that app server pretty quickly. So what we're going to be doing is we're going to be using Azure Data Factory to transport that data from the data lake into the SQL database, bypassing that application server entirely, freeing up the memory for that app server. Now, before we get started today, we are going to have a few things set up. First of all, of course, as all of these, we will need access to the Azure portal and permission to create resources. We'd need, of course, that TimeXtender app server with the ODX storage configured. We also need a SQL server available, an Azure SQL server. So I, of course, am going to be using the one that I created during our second session. We also need an Azure Data Factory available, which I'm going to be using the one we already created during last session. We're also going to need an app registration, and I'm going to be using the one we already created during our data lake session. If you want to know how to create any of these, of course, you can go back in our previous recordings and see me create those in those previous sessions. Let's go ahead and get started. So the first thing we're going to do here is we're going to set up the project. We're going to create a local environment and global database in the environment properties in TimeXtender. We're going to create the database that way, and we're going to plug in our information for ADF. We're going to configure Azure SQL database there. Once we get that database created, we're going to set it to serverless in the Azure portal. We're going to, of course, create the data warehouse storage using that global database. And then we're going to configure schemas to prevent table naming collisions there in the SQL database. Let's jump right in to get started. I'm going to go ahead and open my application server, and it looks like we're connecting to the repository there. And just because that is a serverless database, it does take a few minutes to wake back up. So we might see this actually time out for us here in just a second, and then we'll just connect again, and that'll be just enough time for it to wake back up. We'll give this just a few seconds here. I'm actually gonna take a sip of coffee while we're waiting.
Joseph, we have a couple questions coming in from Rory, and
yes.
We're just clarifying about the how the ADF is required or not to see a preview of the data and also to pull across. So
yes,
there's a follow-up here. Just does it only pull the top 100 across or all records from the table? So I think we have two questions here, maybe. Does that make sense?
Yep, great question. Yeah, so again, I'm going to be using ADF to pull the data from the data lake into the Azure SQL database. And ADF is not required for this. It's just highly recommended. So again, if you're not using ADF, it's going to be pulled into the application server, and the application server is going to be doing that data movement. Now, if your Parquet files are relatively small, then it's not going to impact you too much. We actually can use some settings in the ODX to configure that. If we go in here to adjust our storage settings, we edit the Azure Data Lake, we can actually limit the memory usage here when not using Azure Data Factory to reduce some of that memory usage. And I believe you also mentioned and talked about previews. When you are previewing data, like for example, if you're selecting data here and we're searching through data and we go here to preview a table, what the preview is actually doing is actually looking at a cache of the data. So the ODX is caching just the first 100 records again in the data lake there and allowing you to preview that. And so that's why just the first 100 records are available here in this preview. Again, trying to pull individual records out of a Parquet file is a quite intensive process. Again, unless you have something like a Databricks or Synapse SQL on demand spun up and ready, previewing just a few records of that data can be challenging. So another question here I see, is the memory limit a global limit or a per parallel thread? That is a global limit in there, right? So that's the entire VM or application server saying, okay, you know what, I'm only going to use a maximum of 4 megabytes. And so what this is going to do is this is going to attempt to break out the Parquet files into the column sets, into this various column sets, and just load one column set at a time, or a section of column sets at a time, trying to keep it below that 4 gigabyte limit in this case. So that's how that limitation works for us. It is a global limit, yes. All right, so moving into, yeah, and thank you for the questions, by the way. These are great questions. Again, we're going to create that SQL database, and we're going to do so First of all, we're going to create our project. That's right. So we're going to create a new project here. I'm going to call this TX Tuesdays. I'm going to go into advanced settings, and I want to select show system fields on tables. This isn't a requirement. It's just a preference that I have. It's just nice to be able to see those system fields in the project. And again, this is the TX or the DW ID, the DW batch, the DW source code, and DW timestamp. Of course, these are fields written to every table created by TimeXtender. However, by checking this option, we will just show these fields on tables in the project. So I'll click OK to create my project. And now we can see my project here. Of course, you can see I don't have any data warehouses or anything like that. I want to first create my global databases here in environment properties. In order to create a global database, I have to create an environment. Given that I am in the same app server that I'm running the ODX server, I'm going to go ahead and call this environment prod. I'm going to use this as my prod environment, and then I will create this subsequent environments at a later point in time. So this is going to be, I'm going to use port 10,500 here for my prod environment and click OK. That's just going to create this environment on my local machine here. Go ahead and I will click OK to save that environment. I'll reopen environment properties, and we can see that information saved there. Now I want to click on a new global database. I'm going to call this Azure SQL Database. And this, of course, is a type of data warehouse. So select data warehouse there. Now I need to put in the settings for my Azure SQL database. I'm going to open up my notes here on the side where I have all of this information saved. Now, if you remember, we do have a SQL server running that I created in Azure. This is our TX Tuesdays resource group. I created this SQL server early on, and this is where our project repository is running. I'm going to use the same SQL server here in Azure. I have my project repository there. I can simply just copy the server name, and then I'm going to move this right over into my settings here for the server. Paste that in. Now the catalog, I'm going to create a database here. So I'm going to choose a name. I always like to use the TX prefix here. Put in there MDW, and then I'm going to add a postfix of the environment name. By doing that, if we had more databases, it's easy to identify which one we're looking at here. So TX MDW prod. For authentication, I don't have Azure Active Directory set up, so I'm simply going to be using SQL Server authentication. Get my username and password here that I've saved on the side. Oops. Is there. And my password. Okay. And here we have direct read. When using Azure SQL Database, you always want to use matching server and database. I always recommend using direct read. If you don't have it turned on, please turn it on. If it's not going to work in your environment, it just won't be used. It's always good to just always have it on in the event you are moving from database to database, and it can be used. It's a much faster way to move data. It's faster than using SSIS if you're on-prem. It's faster than ADO.NET. And so by using direct read, you're going to gain those speed benefits. Given that Azure SQL Database doesn't support cross-database queries, you want to use matching server and database, meaning direct read will only be used if the data is on the same database. Of course, the next setting here is to use transfer. I'm going to maximize this so we can see it a bit better. Transfer from ODX with Azure Data Factory. Of course, we want to be using this as well. So I'm going to set this to true. And here we can put in our information. So I'll get my tenant ID. And then, of course, the app registration that I created before. I'm going to put in the app ID. And, of course, the application secret. Resource group name. Subscription ID. data factory name, and the folder name. Again, this isn't required, but it's nice to just keep everything nice and organized in your Azure Data Factory. So I'm going to set this as ODX2 MDW because that's what I'm using this pipeline for. Integration runtime we don't need because we're not using on-prem SQL Server in this. Again, it's just data lake to Azure SQL Database. Now we've finished plugging in all our settings. We want to go ahead and right-click here to create the database. So this is going to talk with the Azure SQL Server using the Azure REST API, communicating up there and saying, hey, I want you to create this database. So this is going to take just a couple minutes for us. And again, just communicating with that database, getting that database created in Azure. We can see if we can follow along here. Taking a look at our SQL Server, go to SQL Databases, and it looks like it's still getting created there. Just go ahead and hit refresh. Still getting created. So again, this takes just a few minutes.
Joseph, maybe I'll jump in here with a question. Daniel
Please.
had asked, why are you using the 2005 plus algorithm and not a newer one?
Oh, I just use the default option. Of course, I can select a different hashing algorithm there if I want to. I just went with the default. I believe you're asking about the settings in my project here. Yeah, this one. This is just the one that's selected by default. I'm not entirely sure why. This is just the one that we found has some good performance. So it's really up to you. Of course, if you want to select a different one, that's you're welcome to do that as well.
Okay. Thank you.
Mm-hmm. Great. So our database was created. Now that our database was created, we actually want to go into the Azure portal. We can find that database. You can see that here. When it gets created like this, it just gets created with the default settings. And in Azure, that default is set to, if we go to compute and storage here, settings. It used to be called configure. It looks like they just changed the name there. So it's set to general purpose Gen 5 2 vCores. That's the default that it's set to. However, I want to be using serverless here. Now, using serverless is going to save us some money in our data warehouse as long as we're using that database less than 50% of the time. If we're using it more than 50% of the time, say you're using it after hours, you're using it on the weekends, then serverless probably isn't going to save you money because hour per hour compared, it's a little bit more expensive than provisioned. However, where you save money with serverless, excuse me, is the ability to auto pause that database. So as it detects inactivity, it will automatically pause and stop charging you for compute. However, when it's paused, you won't be able to access it. Excuse me. And so it will actually, when it detects activity, it'll spin back up, but it'll take, as you saw there in the beginning, it'll take about 30 seconds to a minute to get back up and running. So that's what's going to save you some money there. It's important that you set the max and min when using serverless, the max and min vCores to the same level. I usually pick about 10 vCores. You can decide what's going to work best for you and with your data size. However, 10 is a good place to start. It's relatively fast. The thing that you want to do is you want to make sure the min and max are the same. Now, Azure SQL Database Serverless will scale in the middle as it detects increases in activity. And while it's doing this scaling, it has a tendency, and this is in the SLA for Azure SQL Database, to drop connections. It has a tendency to drop connections. You don't want to be dropping connections while you're running an ETL process, of course. Of course, that's going to cause the TimeXtender execution to fail, and you don't want that. So by setting these to the same, you'll have that solid execution all the way through. You want to enable this auto pause and go ahead and click apply. Another thing you want to be aware of is you want to increase your timeouts in the database as well. So we can go in here to settings. We have our connection and command timeout. I'm going to go ahead and increase these because, again, we want to give enough time for the serverless database to spin back up. Go ahead and click OK and have that ready there. Okay, so we've configured the database. Next, I want to create a data warehouse. I'm just going to call this MDW. I do want to use that global database I just created, Azure SQL Database. Click OK. And then lastly, I want to set up schemas. So I'm going to add a database schema here. I'll call this DBO. Create just my default DBO schema, and then I'll add an ETL schema. And what I'm going to be doing here is I'm going to be setting the ETL schema as the default schema. Okay, and there's a couple different ways you can set this up. You can have a DSA, or you can just simply only have an MDW and hide everything away using schemas. It's perfectly up to you. By just having a single database, however, you do reduce the amount of hops needed to move the data. So we're going to be actually moving the data fewer times by using just a single database. And I can set the default schema to main default schema here, and that will ensure all the tables get dropped into the ETL schema, and then I only want to bring the tables that I want to show to users into the DBO schema. We'll do that now. Click on my SQL Server data source. I'll find a table here. We can use the customer table, and we simply drag and drop that into the MDW. And as you'll see here, by default, that gets pushed into the ETL schema, but I can go to table settings, table schemas, and set the valid schema to be DBO. All right, so that's going to ensure my data consumers, my analysts, can still see that customer table once it's completed. Then I finally deploy and execute. Of course, save my project here. Click save. And you'll see this execution happening now, running those scripts to create the tables. Then it's going to go ahead and spin up that Azure Data Factory to move the data. We can go ahead and see what that looks like here. We open up our TX Tuesdays ADF, author and monitor. I'll open up that Azure Data Factory. In just a second here. Again, go to author. We'll see here in the pipelines, we've created this ODX to MDW. Beautiful. So it's created the pipeline for us. And if we go to monitor, it succeeded. So it ran that pipeline for us just now. We can transfer back here. We can see that data movement was complete. Great. So we're all done. We created Azure SQL Database Serverless as the MDW and using a Azure Data Factory to transfer that data.
Nice work, Joseph. It was great to have those questions while we were underway there, so we're going to skip right into Stump the Chumps because we've just got 4 minutes left. Taylor, do you want to take that away?
Yeah, thanks. So I'd like to invite Anashek Kamal to take the stage, so to speak. Anashek, how are you doing today?
Hey, hi Taylor. I'm doing great. What about you?
Great, thanks. Great. All right. So last we spoke, you had a question. I think you were ready to ask about performance gains and when or when not to use certain settings. What was that question again?
Yeah, definitely. So my question was around merge steps. So I'm trying to set up a scheduled execution package, and right now I'm unsure whether I should select a merge step option, which I saw while I was doing the training, and while I was going through the documentation there, it shows that the merge step can improve performance, but it is not checked by default, right? So given that merge step can improve performance, why would a user not want to enable merge steps? Why it should not be enabled by default? Why we have to check it every time when we do it?
Yes, great question. So this is an option that you may want to select, but you also may not want to select it. And I'll tell you about that right now. So I created in here, as you were asking the question, I created a test DSA database, right? So the data staging area. Now, in production, typically what you'll want to do if you have these multiple layers is you'll want the layer prior to the data warehouse to complete first, just to ensure you've gotten through all the ETL, no problems have come up, no errors have come up. You know that's been completed and you want to complete that first. So what you do here is you drag in the DSA, right? And then you drag in the MDW. And by not selecting merge steps here, of course, I want to set this up to execution time. I'll increase the threads. Now I have this option to merge steps. By not selecting merge steps, this will ensure that it completes this step before moving on to the next step, right? Now, of course, you have, let's say you have, you know, a few hundred tables in here, and then you have like 50 to 100 tables in here. Now, those are a lot of tables. You have to wait for all of these to complete before these will even start going. Now, by clicking merge steps, you will allow the MDW to start executing tables prior to the DSA being fully completed with all of its tables, right? It just needs to have the dependencies completed. Once those dependencies are completed, it can move on to tables in the MDW. However, this means that there's potential that you might run into an error here while it's executing the data warehouse, meaning it could truncate a data warehouse table as it's going through its execution process, and then start running a DSA table, right? And of course, if that error then occurs, your execution process will stop while having an empty data warehouse table. And in production, that could be problematic, especially if you have a lot of other users needing this data during the day. And so by not clicking merge steps, you're going to ensure the DSA completes successfully before it starts moving on to the data warehouse. Again, it will improve performance, but you can run into a situation where you might have empty tables in your data warehouse. Does that answer your question?
Yep, that does. Thank you for answering it. Yep.
Fantastic.
Excellent work, Joseph, and also Taylor. Thank you for all of the links and the answers to questions along the way. We are right now at 30 minutes, so we're going to just wrap it up real quick. Thanks for joining us. We're going to have another session in 2 weeks. Tomorrow we will be sending out the link so you can see this video or share it with other people in your organization. If you register, we will include you in the invite to the meeting 24 hours before the start time in 2 weeks. So please register. A couple of other quick notices. We've got a survey that you can fill out, and you can also suggest topics for us so that we can expand our topic list. And finally, we have a lot of partners that are putting up virtual events, and we are helping to run those events. So if you have an idea for an event you'd like to do, we would be happy to help you. Contact us, and we'd be happy to put together an event for you. So with that, we are going to wind this up. We're just 1 minute over time. So thank you very much again for joining us for TimeXtender Tuesdays, and we will be seeing you in a couple of weeks.
Thanks so much, everybody.
Thank you.